day for everyone. Thank you so much for seeing this presentation. We are the group number 8 and we're talking about the chlorination process in the water purification plant. We start to say we stay in the 13th step of the demand methodology, analyze. Okay, in the content, we have the company background. The product of this company is the drinking water. The activities is dissolved, but we're concentrating in the chlorination process. The location is in Guayaquil. This is a supply chain, and the customers, the most important, is the water consumers. In the project team, we have the project advisor, PhD Clever Garcia, and the project analytics, Sonia Argudo, Fátima Ponce, Bryan del Pezo, and my person, Samantha Petroche. The product focus is since April 2019, the Guayaquil water purification plant has increased its to 6% the average of product out of specification in the residual chlorine during shift 3 of line R2 of the chlorination process. The register has increased of 4% when the company standards is the 2%. Continue with this, we have the objective focus, and this is decreased this percent from 6% to 4% in the shift number 3 in 4 months. We have the D definition. In this case, is the percent of product out of a specification in the chlorine process, and this is the equation that we use. Continue with that, we have the brainstorm. This is the evidence. We have the opinion of different operators and the warehouse manager. This is a brainstorming with the different causes and ideas of this person. We have the interviews, and we can see the most like 13 ideas, but for us, this is the most important. And for these causes and ideas, we continue with the analysis.
So from the brainstorming, we made the Ishikawa diagram, classifying the possible causes as material, machine, workforce, and method, which affect our focus problem. Next, we determine the impact that each possible cause influence the focus problem through the cause and effect matrix, where 3 plant operators rated each cause as 1, saying that the impact is weak, 3, saying that the impact is medium, and 9, saying that the impact is high. So the causes that we obtain a high total value of 27 were lack of standardization in chlorination process, lack of control in the leveling of reservoir levels, variation between the dose of the machine and what the operator enters into remote control, and the last one, lack of knowledge to change the dose. Then, with a control versus impact diagram was made, where we conclude that the causes that have a high impact are easier to control are the causes 1, 2, 5, and 10. And these causes which will be our potential causes.
For the part of causes verification plan, first, the potential causes obtained were taken to demonstrate their impact with respect to the percentage of product out of specification in the chlorination process. The impact range from standardization, variation between the dose the machine and the operator enters, the control in the leveling of reserve level effect, and this will be determined by GEMBA analyzed that are already complete. The first cause, it affects the variable because the dosage of residual chlorine varies. The last one, the variation, 184 data collected in a period of the 2 weeks. In the case the knowledge to change the dose. The process can be determined to be require immediate analysis. The CPQ value is the 0.09. It is a starting point for evaluation the result after the study. And the last one, the controlling the limit of reserve levels, 63. Data we are collecting in the 8 days within shift 3.
Then we have the 5W technique. In this part, we have the 4 potential causes and different rounds for each one. The first potential cause, lack of standardization in chlorination process. In this case, we have two rounds of potential Y. We found 2 root causes. The first, the instructions are too general and outdated, and lack of labeling in the main parts of the process, and so on for the other potential cause. Variation between the dose, lack of knowledge, lack of control. Root causes. We have 5 root causes. The instructions are too general and outdated, lack of labeling in the main parts of the process. The dosing machine is far from the operating area. Standardized criteria for the change in kilogram of deficient chlorine. Lack of visualization of the resulting residual chlorine. And the next step we have for this project is improved. Thank you.